Hi, welcome to your lesson on simple interest. This is a very important starting video on a topic that will follow us in the course for quite some time. We're going to begin with simple interest, and over upcoming lessons, this is going to build into something much more complicated, eventually using your calculator to do some pretty interesting things. For now, again, let's begin with simple interest. So first of all, what is interest? Imagine you and the bank. You and the bank have a relationship. It kind of goes two ways. One way you can have a relationship with the bank is this. The bank gives you some money. In other words, you borrow some money. Let's say you borrow $1,000. We call this capital from the bank. If the bank is giving you money, they're going to want something back. Not just the $1,000 back, but also something called interest, right? Which is extra payments you make, kind of like a borrowing fee, right? But there's another relationship you can have with the bank. So here's you and the bank again. This relationship goes the other way. You give the bank something, right? You're not just borrowing money from the bank, you're also putting money in the bank. So let's say you deposit $1,000 of capital in the bank. Now, if you're giving the bank money to hold, even if it's just holding it for you, they take that money, invest it, and do other things with it. So they have to give you something back for this gift you're giving them, this gift of your money. So they give you back interest as well. So interest can go from you to the bank or from the bank back to you, depending on who's doing the lending, basically, to the other. Okay, so simple interest works this way. There's a formula for it. To find out the simple interest amount, I, we basically multiply C, the capital amount, the principal, like the starting amount that we put in, multiply that by the interest rate, R, and then multiply that by N, the number of interest periods. Looks kind of strange, this formula, but once you see how it works, it's very simple. Let's say Wang borrows $2,000 from a bank at a simple annual interest rate of 5%. It's very important that it notes that this is a simple annual interest rate. Interest rates can become much more complicated, but this is just simple. It means he will just pay 5% on this $2,000 every year. Okay, so how much interest will he pay over 3 years? Let's use this formula. Okay, so put in your principal amount, the amount he borrowed, the rate of interest, and if it's a percent, it needs to be changed to a decimal, and then times the number of years. So in this case, 2,000 was borrowed at 5% times 3 years, and that works out to $300. Now that makes sense. Let's break it down. Let's take this 3 out of the formula and just say, okay, if we have 2,000 and the interest is 5%, so 2,000 times 5%, that would give you $100. So you pay $100 one year, another year, another year. Each year you pay $100 because your interest is only on that original 2,000. So over 3 years, it's 300. That's how this formula works. Very simple. Now let's take that formula and kind of do some more things with it. So let's say we had a capital amount of 1,000 invested in a bank account at a simple interest rate of 300. So you're putting this money in the bank now. You're not borrowing from the bank. You're giving the bank money, and they're giving you back 3% interest because they're basically borrowing this money from you in a way, right? So let's complete this table. After 0 years, how much do you have in the bank? Like that basically means in the beginning. Well, in the beginning, you put in your 1,000. Great. Okay, how about after 1 year? How much do you have in the bank? Well, that requires calculating the interest, right? How much interest is there that you gain every year then? So the interest is the 3% times the 1,000 you put in, and that's how much the bank will give you as a gift for borrowing your money. How much is that? That's 30. Okay, so after 1 year, how much money do you have in the bank? You've gained this much interest, so therefore you have this much money, right? And then after 2 years, and this is again simple interest, they're not going to pay you interest on this amount. They're going to pay you interest on the original amount you put in. So every year you gain only 30 interest. So how much will you have after 2 years? Well, an additional 30 in there. And after 3 years, additional 30 again. So I've laid it out here like this so you can clearly see these values make what kind of sequence? It is an arithmetic sequence, right? Going up by 30 every time. Your bank amount you have in the bank goes up by 30. So this is basically an arithmetic sequence. Can we make an arithmetic rule to figure out how much you'll have in the bank in the future? And remember, arithmetic rules for arithmetic sequences look like this. So can you rewrite that with the amounts based on the sequence? Well, we definitely can. We have 1,000 as our starting amount, U1. And then we have 30 as our D value, the amount it goes up by every time. And we have this. However, I want you to pause and think about this for a second. If you were now to find out how much you have in the future, this formula may not quite work. Let's say I said year 2. How much do you have? Oh no, let's say after 1 year here. So I want to say, what is my U2 here? U2, yeah, 2. Okay. No, so I'm changing the formula to this. Why? Because we don't say after 1 year is U2, even though in this sequence this is U1, this is U2. If I wanted to use this formula in a way where I put in a year number in here, I have to get rid of this n-1. Let's take a look at why. If I said, what's my amount after U1, after year 1, and I want to put 1 in here, if I put 1 in here, what would happen? 1 minus 1, 0, and it would say I have 1,000. So when I'm saying U1, I really mean U2. So I change the rule like this, because now if I put 1 in here, if I say, what happens after 1 year? So U1, and I put a 1 in here, that makes sense. After 1 year, I have 1,000 plus 30, and I have that. So I've changed the arithmetic rule just slightly to adjust for the fact that the 0 year here is U1 in the sequence, but I want this to be called U1 here. Okay, anyway, there's the rule. And you can also rewrite that using the letters we've been talking about in this situation, where this is our starting amount, our principal or capital amount. Then we multiply by the interest we gain every year, and the interest is calculated by doing the principal amount times the rate, right? The principal amount times the rate, and then that times the number of years that have passed. Okay, so given this rule here, which is kind of the same, imagine it just like this here. Given this rule for a particular investment, explain what the values of 1,260 represent in the context of this problem. Okay, so you've made an investment. What does this amount represent, and what does this 60 represent? Well, the 1,200 is the amount, or the capital that was invested, right? The starting amount. And then you're adding 60 every year here. So what does the 60 represent? Well, the 60 is the interest you earn every year. Okay, so then it says, what is the percent interest earned? Well, if you know 60 is the interest earned, how do you figure out what the percent of interest is? Well, you can find out that rate, interest rate, by doing 60 over 1,200, because that will tell you what portion 60 is of 1,200. And by doing that division, we get this, and that tells us the interest rate is 5%. That 60 is 5% of that. Okay, 5% interest rate. So now, again, we have that basic interest formula. We have this kind of rule we figured out to find out any future amount you have in the bank. So let's not confuse this. This formula here is for finding only the interest portion after some number of years. How much interest are you gaining? Whereas this kind of setup here is for finding how much do we actually have in the account, which includes that initial amount of money. So let's say we are told an amount of 5,000 pounds, UK pounds, is invested at a simple interest rate of 3% for 8 years. Calculate the interest received after 8 years. So now it's talking about just about the interest, so we're going to use this interest formula here. But then in B, find the total amount in the account after 8 years. Well, the total amount is the interest you earn added on top of what you put in, right? So let's see if you can get those two values. All right, so here's the interest amount using this interest formula. Here you get 1,200. That's the interest after 8 years. That means per year it would be that divided by 8. Now that's the interest. So the total amount in the bank is your initial amount plus the interest, which is what this formula tells us, right? So it's just the 5,000 you put in plus that 1,200 gives you this amount. Okay, excellent. Let's look at this next one. Reedy invests 4,000 in the bank at a simple interest rate of 7.3% per year. Find the number of years it takes for Reedy's money to double. So in this case, you want the money to double. Okay, so different ways to think about this. But if you want this money to double and he invests 4,000, how much will there be at the end? That amount is 8,000. So if the goal is 8,000, how much has it gone up? Well, it's gone up 4,000, right? If it's gone up 4,000, the 4,000 represents the interest amount, because there's always the 4,000 that he put in there, and it has to go up 4,000. So that's the total interest amount. So you're trying to see how many years does it take for the interest made on this account to be 4,000. So why don't you use the interest formula? And you know the interest goals. The goal is to get 4,000 in interest, right? Okay, so 14 years. Again, if you put 4,000 into the interest formula, which is what's going on here, right here. 4,000 is how much we want the interest to be. Here's the original amount. Here's the percentage rate. And here's n, some unknown number of years. If you solve that, you get 13.69. So you know sometime during year 13, but you know we need this as whole numbers, so it'll take 14 years before it happens. All right, great job. Be ready to talk more about that soon.